Okay, hello, and welcome to freemathhelp.ca. This is the grade 9 specific hour of the live stream. So if you're not in grade 9, feel free to come back at another hour. You can see our schedule on the main freemathhelp.ca page. But if you are in grade 9, please do stick around. We're going to start in about a minute or so. And if you have any questions that don't pertain to what we're learning in the lesson today, feel free to leave them in the chat and I'm happy to answer them for you. Okay guys, so we're going to get started in about a minute and we'll talk to you soon. Okay, so let me just close this here so that we can get started properly. So again, I want to say welcome and I hope you guys are having an awesome day so far. My name is Arlinda and I am the CEO at Scholarly Elite Tutoring, which is the company that is putting on freemathhelp.ca. Today for our grade 9 lesson, we're going to be talking again about linear systems and just diving deeper into this topic because it is basically a 2-unit topic in the grade 9 course. And like I say every week, or if you're new, I just want to let everyone know that you do not have to ask questions that specifically are related to this unit. You can ask questions about anything pertaining to grade 9 math. That's what we're here for, is to answer your questions live for you. But because not every class always has questions, we like to do a lesson every week as well. And this week's lesson is going to cover quite a few things. We're going to do a little bit of a review on the line formula, talk about slopes, and then we're going to talk about actually graphing using intercepts and understanding how to use different methods to graph and find the equations of lines. Okay, so to get us started today, what we're going to talk about first is just a little bit of a review of last week. So if you were here last week, you remember we talked about y equals mx plus b, which we know is the equation of a straight line. So I'm going to pull up a straight line here just so that we can see what we're talking about. So let's do something like that. There we go. Okay, so here you can see that I have a straight line, and what's really important to understand at the grade 9 level is that there are a few key features of this line that we need to be able to pull out at any given moment. So one key feature, when we think about the equation of y equals mx plus b, one key feature that we care about is the y-intercept, and that goes here in the b. There you go. Part of the equation. Wow, my writing today. There we go. And I hope you guys can hear me. If you can't hear me properly, just feel free to leave a comment and I'll start talking a little bit louder. But what's really important for us to understand is also the slope of this line. And we did talk a little bit about this last week, so I guess the whole lesson was on it last week. So we're not going to do this fully as a review. You can go back and watch last week's lesson in our YouTube videos. It's there for you to take a look at if you did miss it last week or if you just want a refresher. But when we're talking about straight lines in grade 9 math, what we're really talking about is a series of points, right? A line is really just a series of points. So I've got a point here, a point here, I've got a point here, and these points can be referred to as ordered pairs. Sorry, my speaking abilities today clearly need some work. So that's really what a straight line is. A straight line is just a series of ordered pairs. And when we talked last week, we discussed what first differences are. And we know that based on that lesson, we know that first differences for a straight line have to be the same because it has to be constant. The slope has to be constant in order for this line to actually be straight. Okay? And it's really important that we understand that a line is just a series of ordered pairs. Like for example, right here, this pair, this ordered pair right here, this point is, let's see here, 0, because the x-axis is at 0 here, and at 6, right? And then here we look at this ordered pair, and this is -1 and 5. So this is something that I find a lot of students don't seem to be told in class. And again, there's some really awesome teachers that do talk about this, but in general, when I've tutored in the past, I have noticed that it's not something that's discussed, and then people get really confused. So this is something when I'm teaching this particular concept that I like to always go over. So let's see here, this is about -4 and 2, no, sorry, where is it? 1.5. And we're going to go through this and understand this a little bit better, but I just kind of wanted to go over that point about how a straight line is really just a series of points, a series of ordered pairs that have been connected. It's like a connect the dot situation. And our goal as grade 9 students is to go in and understand how those ordered pairs relate to each other, whether it's through the slope or through the y-intercept, okay? So when we're talking about a straight line, the reason why the idea of this being a connection of ordered pairs is really important is because if we look here, the x and the y literally just describe the ordered pair. So for example, let's take a look at this line that we've been working on so far and plug in what we do know. Okay, guys? So let's start piece by piece. If you remember last week, we talked about, writing in that each piece of information sequentially so that we have a step-by-step process that we follow. So in this case, there's a couple different ways that we can do this. All right, so one strategy that I like to use is by actually knowing what our y-intercept is, because we have the graph right in front of us, we can actually just plug that in. So I know that in this case, the y-intercept is +6. And I actually know one of the points on the line. I know that this point here, -1, 5, it's right here. You can see where my little star is over on the corner. That point can actually be plugged in and I can solve for m. And if you remember last week we were talking about the slope formula, and we will discuss this again, but this is another strategy that we can use. So I'm going to actually plug stuff in. So if I'm looking at this point, this ordered pair, we always have x first and then y second. And we can take that information. So the x in this case is -1. So I'm going to plug that in here. And the y in this case is +5, because that's the point right here. And as you can see, knowing that the line is a connection, or basically a connect the dots version of ordered pairs, then all we know can be, everything that we know can be plugged in, and we can actually solve algebraically. So one thing that I've noticed a lot in tutoring grade 9 students is that algebra seems to be a topic that people either love or they hate. It's not something that is kind of ubiquitously loved by everybody. And I think that has a lot to do with the fact that everybody had a different grade 8 teacher. Some people's grade 8 teachers focused a lot on algebra, and other people's grade 8 teachers did not. So what I highly recommend, especially during this time that school is out, is if you have time, which I think we all have a little bit of time right now, please go and practice your algebraic skills, your algebraic formulas, and understand how the steps work when you're doing algebra. Because even though it's a grade 8 skill, it's a skill that's required for the rest of high school math, and it's really important to understand it. So what we're going to do here is algebraically solve for the letter m, which is our slope, and we know that slope means the rise over the run. So let's go ahead and do that. So I've got 5 on this side. I want to get everything over to this side as best as I can. So I've got 5 minus 6 equals -1m. Why did I switch that? Because of something in math called the commutative property. The commutative property is like saying 5 times 3 times 2 is the same, well, it's going to equal 30. And that's the same thing as saying 2 times 3 times 5, which equals 30. And this property applies when we're multiplying things. So here, this is technically m times -1, but I can also say -1 times m, and it's more correct to put it this way because you want that to have a coefficient. Okay, guys? So on this side, I'm going to end up with -1, and here I've got this side equals -1m. Well, I know algebraically that when I have a negative, that's not what I want attached to my unknown variable. So I'm going to divide off that negative. And again, if I'm going too quickly or you want me to go over something, feel free to leave a comment in the chat. I know that our grade 9s don't often leave comments, but in the older grades, we have kids who really do leave a lot of comments and they ask questions, and I find that it's a great way for you to be able to get those skills down pat. So that's what we're here for, is to answer your questions, okay guys? So I'm just going to cancel that out. And then here, these negatives cancel out not because they just automatically cancel out, because anything divided by itself is going to equal 1. It could be monkeys divided by monkeys. Because it's the exact same thing, it's going to equal 1. The concept is the same here. -1 divided by -1 is going to equal 1. Okay, and then that's our answer for m. So we now know that the equation of this line is y equals 1x. That's an x. Let me just fix that. Equals 1x plus 6. Okay, so we have now figured out the equation of this line that we see over here in the corner. And what's really great about the fact that we have the equation is that we can now talk about how everything plays out perfectly once we know an equation. So like I said earlier, a line is just a collection of ordered pairs of points that have been connected, and a straight line tells us, or when a line is perfectly straight and it's a linear system, then we know that that line has a constant slope, meaning that it's always going up and over by the same amount every single time. And one thing that we can use that information for is to actually make sure that the equation of the line that we've procured is correct. So I'm just going to change the color I'm working with here. And I know that we have a lot to cover, but the reason that I'm going over this is because in case anyone missed last week, I don't want them to feel super confused for the next parts of this lesson. Okay guys, so now that I have this equation, y equals 1x plus 6, I can actually plug anything into my into my equation is what I meant to say. I can plug any x value into my equation that I know is on the line, and I will get the correct y value. So for example, I know that here I have -4, let me draw a circle where I'm talking about. Right here, this point right here is -4 and 1.5. That's the x is -4, the y is 1.5. So what I'm going to do is plug in where do we go here? 1 times this, sorry, just double checking one thing here. Actually, we're going to use a different part of the equation. Okay, so we're actually going to plug in -2 and 4. It's just going to be easier. So we've got -2 and 4. Whoa. Sorry guys, my digital pen has this like extra button on it that when I press it, it does that crazy line thing. Okay, so let's plug in -2. So I've got x equals -2 plus 6, and I know that when I do that, I'm going to get -2, because 1 times -2 is -2, plus 6, and finally y equals +4, because -2 plus 6 is +4. And I know that that's a point on my line right there. Okay, you guys, so when you know what the equation of your line is, then you can actually use that information to your advantage. Okay, so let's make sure that we understand this concept by trying out something a little bit different. Okay, you guys, so A couple things I want to talk to you about today that are very important for you to understand for this unit in particular are the concept of parallel lines and the concept of perpendicular lines. So in these past couple weeks that we've been learning about linear systems and understanding how straight lines work and what they mean, the main topic that we've been discussing is slope and the importance of understanding what the slope is. So again, when we talk about slope, slope is equal to the rise of the line over the run of the line, meaning how many units does it go up and how many units does it move over. So this is vertical and this is horizontal. And the thing that's really, I would say, most important to understand is that slope doesn't necessarily determine where the line is in the space, in the Cartesian plane that we see, right? What really tells us where it's going to land is our y-intercept, okay? So keeping that in mind, what I want to talk about today when we're discussing parallel lines is this concept that parallel lines have the exact same slope. And why is this the case? Well, I'm going to show you. So let's say, for example, I had a perfectly straight line right here, and it's going through the y-intercept of 0, 0. Oh gosh, 1 second. Let me fix that. It's the hard part about using digital technology to draw my lines. Okay, this is about good. Okay, so here I have a line that I know has a slope of 1. How do I know that? Because basically if I look at it, I'm looking at point to point, it goes up 1 and over 1, which means it's going to be the rise over the run is 1 over 1, and that gives me a slope of 1. Okay, but don't let that confuse you. We're going to basically explain what the heck I'm talking about. So let's draw another line with a different color. Let's do green. I can never decide with these colors. They're too much fun. Okay, so let's say that we're doing a different line with the exact same slope. So again, I want my slope to move up 1 over 1, up 1 over 1 every single time. So if you can look here and if we were to actually, you know, have protractors and all of that fun stuff available to us, we could see that these two lines are parallel. Parallel just means that these two lines are both going straight and they're never going to touch each other. If they were to go on forever and ever and ever and ever, these two lines would never come into contact with one another. And the reason for that is because they have the exact same slope. Because if you're oh, let me get rid of my arrow, need my drawing utensil here. So again, this line, the green line, is also going up by 1 and is also going over by 1. And what's very important for us to understand is that in doing so, it actually makes it impossible for these two lines to ever touch. But the thing that we need to understand about these two lines is that even though they have the same slope, they're obviously not overlapping, right guys? You can obviously tell they're not, you know, overlapping at all. So the reason for that is because the green line has a different y-intercept than the purple line. So if we look at the green line, we have a y-intercept right here at +4. And if we look at the purple line, we have a y-intercept here at 0. Okay, so let's write these out. So for the purple line, I have an equation. And remember, I know that my slope is 1. So I have an equation of y(x) plus 0, which is the same thing as saying y equals 1x, which is also the same thing as saying y equals x. These are all the same, okay guys? So this is the same as this and this. So if we talk now, or if we're going to discuss the green line, we've got the exact same slope. So it's going to be y equals 1x again. But in this case, it has a y-intercept of 4, which I need to indicate here. So that's our final version of this line. So this is what I wanted you guys to understand, is that when we have something like this, it's very, very important that you understand that even though these two lines are parallel, they don't have the same y-intercept, okay? And you will get questions like this on tests, and I know that right now testing is a little bit different than usual, but the likelihood is that if you guys haven't done this unit yet and your teacher is going to assign it in the next little while, it's going to be something that you need to understand, okay? So this is the easier part of this unit. Not the easier, but it's easier than the next thing we're going to discuss, which is perpendicular lines. So we were just talking about parallel lines, and now we're going to discuss perpendicular lines. So what does perpendicular mean? Perpendicular lines. It is a line that perfectly goes across, and I'll show you what I mean because it's hard to explain without a visual. So let's take a look at this. So let's say, actually, let's break this down piece by piece. So we're going to start, instead of me drawing the lines first, I'm actually going to draw the equation first. So let's say I have a line with an equation of y equals 3 over 2 x plus 1. That means that my slope is positive 3 over 2 and my y-intercept is positive 1. Okay, so let me draw this line. Well, the best way to draw a line is not to just wing it, although I do know one point here, so I know that positive 1 is a point on here. But instead of just winging it, I'm going to create an x and y. Wow, cool, straight line, way to go. I'm going to create a straight line here to use my x and y. So we know that y equals 3 over 2 times x plus 1. So let's say I was to plug in, for example, the number 1. I know that my y is going to be 3 over 2 times 1 plus 1, which is going to equal 3 over 2 plus 1, which you can either write like this. Oh, no, sorry. My bad. We're going to make it a common denominator, which is 3 over 2 plus 2 over 2, and we're going to get 5 over 2, which is another way of saying 2.5. So I know that 2.5 is one of my points here. So at x equals 1, we've got 2.5 is the y. Cool. Let's plug in negative 1 as well, because we always want to plug in 3 points to make sure that our line is actually going to make sense, because just with 2 points it's not enough to tell us whether or not this is going to be drawn correctly. So let's say I do 3 over 2 times negative 1 plus 1, then that's going to be negative 3 over 2 plus 1, and we can just bring this up here, equals negative 3 over 2 plus 2 over 2, which is going to be, I always scratch this up, negative a half. So I know now that at negative 1 and negative a half, oh, yeah, my bad. It's not that, it's going to be here. Right here. Okay, so let me use that information to draw this line before it gets any wonkier. So I'm going to do this starting here. There we go. Oh my gosh, you guys. Technology is just not on my side today. We had a lot of technical difficulties getting the stream to work for some reason. I don't know what was going on with YouTube today, but I appreciate everyone joining us. Okay, so this is a straight line. We just figured it all out here. Now what we're going to do is create a perpendicular line to this line. So the whole reason that we're talking about perpendicular lines is because after learning about parallel lines, it's important to understand that a perpendicular line is the negative reciprocal. And I'll show you what that means. So if our original equation was y equals 3 over 2 x plus 1, then we need to find out the slope that is the negative reciprocal of 3 over 2. Well, I'm going to show you guys how to do that. We're going to get a different color pen here. There we go. So if this original slope was 3 over 2, the negative reciprocal of that slope is negative 2 over 3, because we flip the fraction and make it negative. And when I say make it negative, I mean multiply it by a negative. So if the original slope was negative, it would actually become positive. Okay, guys? So a negative reciprocal slope doesn't necessarily have to have the same y-intercept. But in this case, I'm going to make it have the same one just to illustrate the point that I'm trying to make here. So again, we know that because it has the same y-intercept, that same place is going to have a point there. And we're going to use the same method that I used just now to show you guys how to find the points for here. So we know that y equals negative 2 over 3x plus 1. And again, guys, if you have any questions as I'm going through this, or you're confused by anything, or even just have questions that don't have to do anything with this, you're more than welcome to leave them in the chat and I will answer them, okay? So let's do the slope equals 1, or sorry, the x is 1, so y equals negative 2 over 3 times 1 plus 1. So here we go, and we've got negative 2 over 3 plus 1, and then we're going to make that a common denominator. Sorry, plus 3 over 3. And this is going to be like that. And that actually is our y point. So it's going to be somewhere 1/3 of the way. So right about there. That's one of the points. Great. And then let's do negative 1, just because those are usually the easiest ones to plug in. And I always tell people, I find that grade 9 seems a lot more crazy than it actually is because we try to complicate things. Just keep things simple and it'll make your life a lot easier. So this actually becomes positive 2 over 3 plus 1, which is 2 over 3 plus 3 over 3. And I'm going to bring this up here so everyone can see. And we've got 5 over 3. Perfect. So we're going to find that here. And again, you typically would want to leave things as fractions, but just so that you have a good sense of where things are, we know that that's going to be 1.666, something like that. So negative 1 is going to be somewhere like here for our y. Great. So we know that this line, if I could get it a little bit, it's hard to get perfectly straight lines because obviously this is a computer program. Okay. Oh, we were so close there. Should be something like this. Okay, guys? Great. Okay, guys, so these are two perpendicular lines. And one thing that we want to make sure we understand is that when we have a perpendicular line, we can see in the graph that they are perpendicular because inside here, oh, let me get rid of the arrow function. Here where they intersect and perpendicular lines will intersect, we've got 90-degree angles in here. So these have to be perfect 90-degree angles. So again, just to reiterate the point of what we've been talking about so far, a perpendicular line has a slope that is a negative reciprocal to the original line you're talking about. So that means that the slope itself, if it's a fraction or even if it's not a fraction, you have to flip the fraction and multiply it by a negative. Alrighty, guys? So when we talk about perpendicular lines and parallel lines and all of that fun stuff, typically what you're going to be shown in class are not necessarily graphs. You're going to be asked by a teacher something along the lines of find a perpendicular line, or find a line. Oh, where's my grammar, guys? Oh my goodness. Find a line that is perpendicular to the line y equals 5x plus 4. Okay, well, we can definitely do that based on the information that we just learned. If you recall, a perpendicular line has a slope that is the negative reciprocal of the original line we're discussing. The reason I picked a whole number as our slope, right here, the number 5, is because this is often how people get tricked. And I say tricked, I don't mean your teachers are trying to trick you. I mean that our brains get tricked into forgetting that every single number that we encounter is always over the number 1. It's technically a fraction. Even when you see a number by itself, it's technically over the number 1. So if we have a slope that is 5, we actually know that that slope is 5 over 1. Okay? So let's go ahead and create some perpendicular lines here. Well, we know that a perpendicular line to this line that we're looking at here has to have a negative reciprocal slope, which means that I'm going to flip this fraction and make it into 1 over 5 and multiply it by a negative. Oh, let's separate those so you guys can see what I'm talking about. Make it into a negative. And one thing that kids always used to ask me when we would be tutoring is, you know, does it have to have the same slope? No, it does not necessarily have to have the same slope. It can, and sometimes it does, but if your teacher's asking you to find a line that is perpendicular, you don't have to have it have the same slope. So in this case, I'm going to make the slope positive 7. And another perpendicular, you know, this line is perpendicular to the original line. We could also say that y equals negative 1 over 5x minus 30. That's also perpendicular because, again, it's just flipped. It's just that line, the original line, with a negative reciprocal slope. Okay? Let's do an example where the slope is negative, because these are the ones that people often have a hard time on tests, and I think that it's important to understand how we're going to approach that. So say my original line was y equals negative 10 over 7x plus 42. Just throwing some numbers out there, okay, guys? So let's say that this was my original line. Okay, no problem. We know that we want a perpendicular line to this line. Well, all we need to do is get a slope that is the negative reciprocal. And a lot of times kids will ask me, well, what the heck? The slope is already negative. How am I supposed to do that? All you're doing is multiplying the original slope by a negative. So that means that it's going to become a positive. So let's go ahead and find those perpendicular slopes. Let's use a blue marker here. So a perpendicular slope to this one, or a perpendicular equation of a line, would be, first we're going to flip the fraction, so go right ahead and do that. We've got 7 over 10 instead of negative 10 over 7. And then because this original fraction was negative and I'm multiplying by a negative, it's going to be a positive. So now it is 7 over 10. Hi, Eva. So wouldn't flipping it affect x plus 4? Let me just go back. Sorry, guys, because you guys are on a bit of a lag, so sometimes I've already moved on when I see people have asked a question. So let's go here. See what question she was looking at. Flipping it. Affect x plus 4. Eva, can you elaborate which question you're asking about? So when we flip the slope, it doesn't affect the second part of the equation. I just want to see if I'm missing what it is that you're particularly asking for. Hopefully that makes sense. So just kind of to answer Eva's question specifically, when we're flipping the slope, we're not flipping the slope of the same line. We're just finding a different line. So ultimately what's happening is that we're using the original equation to determine what would be a perfect perpendicular line. What's going to intersect that line, or what's going to perfectly be the opposite. When I say opposite, I mean negative reciprocal of the original line. So hopefully that makes sense. If I'm not answering your question fully, Eva, please feel free to ask a follow-up. Effect plus B. Oh, okay. So yeah, that's a very good question. So it doesn't necessarily affect it. So I'll show you what I mean, because these are different lines, right? So if we look back at this question, the plus B is kind of its own thing. So this could be, we could have had another perpendicular line, and it could have been y equals negative 2 over 3x plus 5. These are just totally different lines. So that would be here, and I'm just going to make some quick, it'd be something like this. So it doesn't affect it because it's a completely different line. So that's the reason why. It's not that we're actually changing the original line, we're just finding a line. Karen, what's 3 root 45? So Karen, to answer your question, let me pull up a new page here. So Karen, your question can be answered in two ways. Are you asking what is the third root of 45? Or are you asking what's 3 times the root of 45? Eva, yeah, Eva, thank you. I hope that that was helpful for you. Sorry, I know that I was kind of flipping back and forth. But yeah, no, that's actually a really good question that Eva asked, because this is something, again, that when I've been tutoring in the past, I notice many people wonder, because it does seem like that at first when you're learning it at first. So Karen, yeah, just please clarify as to which of these two questions you're asking, because they're two different, completely different questions, and I want to make sure that I'm addressing the right one. We can go over both. So just in case. So Karen, whenever you have a second, just let me know, and then we'll answer that question as well. So the question Karen's asking, depending on which of these two questions it is, one of them is more of a grade 9 question and the other one is not, but that's okay. So the third root of 45 here is approximately 3.557 if you were to round it. And then here, 3 times the root of 45 is a bit of a different question. It's actually, this is more of a grade 10, 11 question, but I don't mind going over it if it's something that you were wondering. 3b plus b equals 4b. Yep, that's correct, Karen. 3b plus 4b, 3b plus b equals 4b. Perfectly correct. Hopefully that makes sense. Okay, so third root of 45, this is 3 times the root of 45 is really just 3 times 3.557. And there is a different way to do this that we learned in grade 10. That's a little bit, we could say a little bit crazier or harder, but it involves a full lesson. So if you want Karen to come back for the grade 10 lesson, we can definitely do that as well. But yeah, so hopefully this answered your question there. So we've got about 20 minutes left, and I want to make sure that we are addressing a couple other things. So hopefully the parallel and perpendicular line thing makes sense to everybody. If it doesn't, feel free to ask any follow-up questions that you might have in the chat as well. But yeah, so like I said, Eva's question is actually a perfect question, because It is something that gets asked every time I've tutored this subject. People are always wondering about that, and it's a very, very good thing to understand that these are different lines. It's just that we're using the original line's slope to determine the perpendicular line slope. Okay, guys? So now that we've got that down pat, what I want us to do, okay, just doing some erasing here, no big deal. Okay, so another thing that I want us to understand really, really well is the coordinate, whoops, there we go, of the y-intercept is a very useful piece of information. Okay, guys? So when we are discussing a straight line, whatever the straight line is, understanding that the coordinate of a y-intercept, like say we have y equals, 7x plus 20. Well, what does that make the y-intercept? Well, we know it's positive 20, but what is the actual ordered pair? The ordered pair is going to be 0, 20. Why is this the case? Well, something to remember is that for the y-intercept, the x value is always 0. Okay, so that's something really important to remember because it actually gives us a point to use sometimes when we're given questions that require us to solve for the equation without knowing a lot of information. So this is something very, very important. And one thing I do want to stress as well, and I don't want to confuse you guys, so I'm going to put it over here, is that the x-intercept is also a thing that exists, and sometimes you will be given that information. And the x-intercept always has a y value of 0. Has a y value of 0. Well, why is that the case? Let's talk about that. Okay, guys, so let's draw a straight line here, just kind of arbitrarily. Bop, 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 bop. Okay, so let's talk about our, let me draw that better. Goodness gracious. Let's draw that a little bit better. Just trying to get a perfect x-intercept here. Okay, so if we're talking about our x-intercept, and we know that that is right here. Oh my gosh. There we go. We know that our x-intercept is right here. What is an intercept? It's literally where the line intersects the x-axis or the y-axis. So in this case, this is the x-axis, this guy right here, the straight line that goes across. And we know that we are intersecting the x-axis at -4. That makes the value of this ordered pair -4 as x and 0 as y. Why is the y 0? Well, that's a y. The y is 0 because we are not off of these 0 points. So here, if we look as we go across, if the y value was any higher, it would not actually have hit the x-axis. Now let's talk about the y-axis and the y-intercept, which is actually the one that matters most for grade 9 math. So let's use this purple, it's kind of pretty. Let's take a look here at something like this. Oh my gosh, I did not want that. Every time I think I'm using a straight line, I'm not. Every time I think I'm using the pencil, I'm using a straight line. Okay, so let's go back to the pencil quickly. So here we have the y-intercept. Ye old y-intercept, as they used to say in medieval times. So the y-intercept right here. And we can actually determine what the value of this is, or what the ordered pair is going to be, just by knowing what the y-intercept is. Well, we know that no matter what, if the line is crossing the y-axis, that the x value has to be 0. Okay, guys, like I said, I know this seems a little bit redundant, but it's something that people kind of think they know instinctually, and then they get onto a test or they're doing an assignment and they're like, wait, which way is it? If you're confused when you're writing a test or whatever, don't try to think, okay, well, which one was it? Instead, literally just draw yourself a line and actually look on the line and say, okay, well, the x value of this line is 0 because I'm right in the middle. I'm right at the y-axis, so it has to be 0. Okay, guys, so keeping that information in mind, and again, if you have any questions or if I'm going too fast, do not hesitate to let me know. I'm happy to go over anything. So we know that the x value at the y-intercept is always 0. And so now that we've kind of covered all of these main topics, what I really think is the most important thing to understand is how to use all of that information that we've learned today and last week. And again, if you missed last week's session, it is live on it's not live, but it's on our YouTube channel in video form for you to go ahead and take a look at so that you can refresh any of these skills that you're not 100% sure about. Okay, so what we're going to do is, let's say that your teacher gives you a question and it says, what is the equation of a line that has a y-intercept of 4 and intersects the point, let's say, negative, I don't know, 12 and 20. Okay, let me just move this over here. So let's do that. Let's go ahead and solve this question. This is a very common type of question that you will get on your tests, and that it's really important to understand. So they're asking us, what is the equation of a line that has a y-intercept of 4 and intersects the point negative, or goes through the point, we'll say, goes through the point negative 12, 20. Okay, well, everything we've learned so far has been leading up to this very moment, okay, guys? So remember that whenever we've been given a y-intercept, we actually know the point that exists there. So we know that at every y-intercept, the value of x is going to be 0. So this is actually the point, the ordered pair as we call it, x and y, where the y-intercept exists. So if we recall from last week, obviously we know that the equation of a line, and for most of the time, our teachers want us to put it in this format. Well, there is an equation that we can use to solve for the slope, and that equation is m equals y2 minus y1 over x2 minus x1. Okay? Now, let's kind of go ahead and break down what the heck this means, because clearly this is a lot to take in. So again, I'm going to outline my 2 points. I've been given 2 very specific points here. I've got 0, 4. Trying to draw my 4 so it looks like a 4. And I've been also given, that's an and sign. Guys, my writing today leaves much to be desired. Let's fix that real quick. 0, 4, and again, wow, you know what, I give up on the and. Negative 12, 20. Okay, you guys, so with this information, the first thing that I want to do is number these. So I'm going to call this ordered pair 1, and this other one ordered pair 2. And the way that I'm going to indicate that is I'm going to say x1, y1, and x2, y2. And one thing that I've had many students ask me about is, what's with the numbers? Do I have to multiply it by this number? Like, what the heck is going on with these 1s and 2s? All that those numbers are they're called subscripts, which means that they're just a little indicator to you that this is ordered pair 1 over here, and that this is ordered pair 2. You don't have to use those numbers to multiply or anything. The only reason that we actually label them is to make our lives a lot easier. And this is something that I highly recommend you do. Even if you've been given the points in the question, rewrite them and actually write the labels above them. Because when you're rushing on a test to get things done, it makes it much, much easier. Okay, guys, so let's go ahead and use these this information to solve for the slope. So the M formula, as we know, is y2 minus y1. And again, the best thing you can do when you're writing a test is rewrite your formulas. Teachers love that. Honestly, I can tell you from marking experience that it is so much easier to mark when someone has everything really perfectly outlined. And oftentimes I find that girls actually get better marks than boys in general. Like, not overall, but I mean girls actually get extra marks on their tests for being super organized. And again, that's like not a definitive statement, but I have seen that over and over again as a pattern throughout my tutoring career. So let's go ahead and get these numbers plugged in. So I'm just going to use a different thing here. So I've got y2, which is 20. I'm going to plug that in as it is, minus y1, which is 4. And that's going to go over negative 12 and 0. So negative 12 minus 0. So a lot of times I see kids will lose marks because they aren't sure whether or not to change the negative or what to do here. So let's say that we had the things reversed and it was 0 minus negative 12. You actually keep that negative in there. This negative is what I'm talking about. This subtraction sign. You don't change that just because the number is negative. It doesn't matter if the number is negative. It'll be negative, negative, and you'll make it a positive. But we'll do another example so that that makes a little bit more sense. So let's say that we're getting this answer here, and we want to go ahead and make sure that everything makes sense. So 16 over, so that negative now goes in the front because negative 12 minus 0 is still negative 12. And then we've got negative 16 over 12. Well, this can be reduced. As we know, it's going to become negative 4 over 3. And again, reducing, what is 12x plus 13? Hi, Karen. Yeah, I'll do that in just a quick second, okay? So, yeah, and then basically from here, we have our slope. And we can actually solve the whole equation because we've already been given our y-intercept. So the whole equation is going to be y equals negative 4 over 3 x plus 4. And that's the whole equation. We're going to do another example, okay? Awesome. Thank you, guys. I really appreciate you guys asking questions. So to answer Karen's question, what is 12x plus 13? That's a very interesting question because actually, if we erase these guys here. So 12x plus 13, unless I was to have a little bit more information, and maybe your teacher has put another part of the question here, 12x plus 13 is basically the final answer to whatever the question is, because 12x is not a like term with positive 13. So this is going to be the final answer. But if it's equal to something, Karen, I can give you the final answer for what x is. Like if this whole thing, let's say 12x plus 13 was equal to 0, then we can go ahead and solve for x by going like this, because we moved the 13 over, and then we divide off the 12, and then x equals negative 13 over 12. But that's only true if the original question is equal to 0. Okay? So hopefully that makes sense for you guys. And Karen, if that's not the question that your teacher was asking, feel free to go ahead and give me some more information and we can go ahead and do that, okay? Awesome. So hopefully that helps a little bit. Cool. Going back here. Okay, guys, so remember that, we kind of discussed a couple things today, just as a review. We talked about parallel and perpendicular lines and how we can use the information that's been given to us to solve for parallel and perpendicular lines. And we know that we have our slope formula. Well, one very common type of question that I see all the time on tests, and I'm going to go ahead and erase this so that we can put in a new type of question. And next week, what I'm hoping to do is go over some of the word problems that come up in this unit. And I know that that's a big area that a lot of people really don't enjoy. So I want to make sure that we have time to cover that, which is why we didn't do it this week. But again, before we finish the grade 9 class, if you guys have any questions that you want me to quickly answer, feel free to leave them in the chat and I'm happy to do so. But yeah, so given all the information that we've got so far, let's see if we can answer a question like this. So solve the equation of a line that we'll say passes through negative 15 and negative 10 and negative 20 and negative 8. Okay, so let's go ahead and solve this equation, okay guys, before we have to go here. So remember, we want the equation to be in the form y equals mx plus b, and we're going to solve for m using this formula, y2 minus y1 over x2 minus x1. And the way that we can do that is literally by rewriting these numbers and giving them their proper values. So I'm going to call this one x1, this one y1, and this is x2, and this is y2. And like I said, it's super important to make sure that you're labeling everything. It makes it a lot easier. So let's go ahead and plug stuff in. We've got y2 is negative 8, if I could write the number negative 8 properly, goodness. And then y1 is negative 10. So remember what I was saying earlier. The original equation is y2 minus y1. That doesn't mean that if the y1 is negative that we change the original equation. That subtraction sign stays where it is, and then we go negative 8 minus negative 10. Okay, and then we're going to fix that in the next question using our integer rules. So, or in the next step, sorry. And then x2 is negative 20. And again, keep that subtraction sign there. And x1 is negative 15. So using our integer rules, this is now going to become negative 8 plus 10. And this is going to become negative 20 plus 15, which now makes this top answer. So remember, we do the numerator separately and the denominator separately, and then we go ahead and solve for the final answer. Okay, guys? So this is going to be positive 2, and this is going to be negative 5, which in actuality is going to be negative 2 over 5, because again, whenever we write this out, we always want to make sure that that negative is in the numerator, or basically in the middle, and that's going to be our m value. And now that we know the m value, we can actually solve the rest of the equation, aka the intercept, using the information that we have. So I'm going to just use a different color here to make things a little bit easier to see. Okay guys, so let's solve the rest of this equation. I know some of the equation already. I have y equals negative 2 over 5x, but obviously that's not enough information. Hi Roman, we're going to get started with grade 10 in just a second. So we are going to now plug in one of these points. I'm going to pick this one. And remember, this is an x value, this is a y value. And like we were saying at the beginning, a straight line is just a series of ordered pairs that have a constant slope. So here we go. We're going to plug this in. We've got the x here, so we're going to go negative 2 over 5 times negative 15. Oh, this is a 5 plus b. And the y goes here. That's negative 10. So overall, we've got negative 10 equals negative 2 over 5. Hi guys, if you're here for the grade 10 class, we're going to get started in just 1 second. We're just going to wrap up grade 9 here quickly, okay? Plus b. So let's go ahead and solve this here. So negative 2 times negative 15 is going to be 30, and divided by 5 is going to be 6. So we've got negative 10 equals 6 plus b. And then I can just move this 6 over, so it's going to be negative 10 minus 6, because it was positive on this side, equals b, and then negative 16 equals b. So our final answer here is going to be y equals negative 2 over 5 x minus 16. Okay, guys? All right, so that's everything for grade 9. And I hope that you guys had a good time here for the hour, and we will be back at same time, same place next week, but we're going to get started with grade 10, and we'll see you guys next week if you're in grade 9. And if you are in grade 9 and you want to stick around for grade 10, you're more than welcome to. Okay, so I want to welcome the grade 10 class and hope you guys are having an awesome day so far. We are going to get started on some grade 10 work, and as always, if you have any questions, please feel free to leave them in the chat. That's what we're here for, is to answer any questions you might have. And we're also going to do a lesson today for grade 10, and we've been amping up to this lesson for a little while, and it's all about vertex forms. So if you are wondering about vertex form or you want to review a vertex form, that's what we're going to do today, you guys. So hope that you are well, and let's get started on talking about vertex form. So quickly, before we jump right into vertex form, we want to talk about quadratic equations and how there are 3 main formats that we can see our quadratics in. So not equations, sorry, quadratics in general. So quadratic form is the form that looks like this: y equals ax squared plus bx plus c. And we've got our vertex form, which is y equals a x minus h squared plus k. Like I said last week, this is the one I call Hong Kong form because it's got the hk there. And last but not least, we have factored form. So these past few weeks, we've talked a lot about factored form and quadratic form, but today we are going to hone in on vertex form, which is actually the part of this unit that I find most people really struggle with. And so I wanted to dedicate a whole session to it because it does involve quite a few different concepts. Okay, guys? So one thing that I want to make very clear is that just because these are 3 different forms, that doesn't mean that they're not all talking about the same line necessarily, or the same, equation or whatever. Let's see what we can draw here kind of arbitrarily. So say we have this equation, right? And I don't know what this equation is off the top of my head, but let's say that this is like 2 or something. And this is a quadratic type of question, quadratic form, I guess you could say. But basically this graph here can be explained using any of these. You could have written it in this format, you could have written it in this format or this format. All that we use the different formats for, realistically, is to just describe different aspects of the graph. Okay, guys? So today what we're talking about, as we know, is vertex form. This guy here, trying to draw my star. We're talking about vertex form, and what's really important to understand about vertex form, wow, my star just got really out of hand there. What's really important to understand about vertex form is that it does tell us some super important information. So let's say that we're breaking it down here. So just as with, even linear equations like we were just talking about in grade 9, or quadratic, any type of formula that we're looking at or equation that we're looking at, what we really always need to remember is that x and y are just pieces of an ordered pair, right? So these are not actually necessarily indicators of how the graph is looking. These are just things that we can plug in to solve for, right? X and y. But the rest of these pieces are really important because they tell us a couple of things. So the A, we know this tells us the direction of opening, and it also tells us whether or not we're going to have a maximum or a minimum, and we're going to discuss that in more detail in the next slides, but this is just kind of a general overview here. And then the HK, Hong Kong, tell us the vertex. So what is a vertex is probably the main question that we should be asking in the beginning. The vertex is either the maximum or minimum point in a quadratic graph. So here, if we look here, this vertex right here is at let's say that this was like -3, for example. This vertex right here is -3, and positive 2 as our x and y values. Okay, so let's get into this a little bit more intensely so that we can understand what the heck we're talking about. But basically, like I said, today we're going to be discussing the various aspects of vertex form. First and foremost, we're going to talk about how to convert from quadratic form to vertex form, because that is a super important skill that definitely matters for all of the rest of math. And another thing that we're going to be talking about is using that information that we gather from being able to do that in order to graph a vertex form question. So let's go ahead and talk first about converting between the two. So this is a form, kind of a algorithm that a lot of people refer to as completing the square. And we are using it, or we're going to use it, to convert between quadratic to vertex. So we know that that is equals y equals ax squared plus bx plus c. And here we've got y equals ax minus h squared plus k. So the reason that these letters are different, except for a, because a is always going to be standard. It's going to be whatever the a was in the quadratic form, it's going to be the same in the vertex form. And I'm going to show you why and how that works. But when we're talking about converting between them, we're still talking about the same exact graph. Like I said, you're just describing it differently. It's like someone saying, you know, this, I'm trying to think of an example. Kind of like saying, okay, the sunset is gorgeous, and someone else describing it as the sunset is beautiful. It's just two different ways to describe something, but you're describing the same thing, okay? Except in this case, you're actually using that description to give you valuable information, because unlike a sunset, a quadratic formula is going to give you an answer that is going to give you a graph, and that graph is pretty much standard for a certain equation. So let's go ahead and talk about how we can go ahead and do a step-by-step breakdown. So again, we're starting off, and actually let me do some erasing here to give us some space, because this is going to take quite a bit of space. Let's do purple. I'm feeling like a purple pen color today. And again, as you guys know, if you have any questions about what I'm teaching, you're more than welcome to leave them in the comments. If you have a question that has nothing to do with what I'm teaching, that's also cool. You can leave that in the comments, and I'm happy to take a break from what I'm teaching to talk about your question. That's what we're here for, guys, to provide answers to the questions that you have, okay? So one thing I want you guys to understand, first and foremost, is that when we're talking about converting from quadratic to vertex, whatever's going on, whatever we start with, we want to make sure that all of this stuff is moved to one side of the equation. So again, I want to make sure that it's not, or it is in the format of ax squared plus bx plus c when I start, okay? Now, I'm going to start off with this question, 5x squared minus 2x plus 2, because it really does help us illustrate all the points that we're going to be talking about, okay? So this is where I was saying last week, you know, if people wanted to join us, because it's actually, this is one of my favorite things to teach, because I have a crazy little method that I use. It's the same method, I just use different words to describe it, and I find it easier to remember. Okay, so enough of me blabbering, let's do the math. So, oh, there we go, just fixing my pen here. So when we start off with a question like this, the first thing I'm going to want to do is put some brackets around the A term and the B term. And I'm going to do what I like to call exiling the C term off the island. He's got to go. We don't love him. He's leaving. So C term by himself, okay? And what I'm going to do next is I'm actually going to factor out the A term. And the way that I do that is by dividing it out of the A and the B. So go right ahead and do that division. And if you're following along, I highly recommend literally writing these steps down, okay? So put some equal signs here. Okay, so now in my next step, that's going to look like this. The A term has been factored out, so it's now in the front of the brackets. I no longer have anything in front of x squared, so it's just going to be that. And then here, I have minus 2 over 5x. My number one tip for you guys, at this point, do not get rid of the fraction. If it's a fraction, do not do a division to have a decimal. Decimals are super annoying, and I'm going to show you why. It's actually much better to leave things as fractions, and something that I didn't learn until university when I was taking a calculus course. I had this really awesome professor who told us that decimals are actually not the most accurate form of answer. It's actually better to leave things as a fraction, okay, in general. So what we do at this point is something that I like to call the death box. I know it sounds super morbid, but it's a very easy way to remember this. And actually, this is something that I teach all my students. And if I've actually had students like figure out that they're both my students because of the death box, like people sitting in class next to each other, calling it the death box and then realizing like, oh, I think we have the same tutor. And it's now something that we teach all of our kids, so, or all of our students at Scholarly Elite. So in general, at this point, you take this new B term that you've created and you take it with the subtraction or addition sign that's in front. Okay, so in this case, it was negative. So I take it as a negative and I bring it over here to my death box. And what I'm going to do is what I like to call chopping off its head. So I'm literally going to multiply it by a half, and that's going to chop him in half. And when we multiply by a half, instead of dividing by 2, it makes this a lot easier because multiplying by half and dividing by 2 are the same thing, right? We know that. But a lot of times teachers will say, oh, just divide it by 2, and then people get super confused. When you multiply it by a half, it gives you a standardized way to do this every single time that will give you a very simple version of what you're trying to do. So in this case, I have negative 2 over 10. And then this thing that I just chopped in half, I'm now going to take as is, again, with its negative, and I'm going to square it. And when we square something, that means we multiply it by itself. So here we get 4 over 100, which is also 2 over 50. Okay? So I'm now going to take this number, 2 over 50, and actually, sorry, that's my bad. It's actually 1 over 25, the most reduced version. So I'm going to take this here and I'm going to plug it back in to my original equation. So I've got 5. So see how pretty much everything else is the same. I'm literally just adding this new thing that I created, this Frankenstein that I've created over here. So x squared minus 2 over 5x, that's the same. And now I'm going to put positive 1 over 25 and negative 1 over 25. And then obviously this part's the same as well, plus 2. Cool, 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 cool. So let's go ahead and do the next step now. So again, if anything about that confuses you, feel free to leave a question. I'm happy to answer that, okay? Again, we're going to do more examples of this. This is not the only one we're going to work on, but this is a very straightforward one that helps us kind of understand how to use all of these steps. Okay, so now we've both added and subtracted this number that we got in the death box. And what we want to do is actually get rid of the negative version because we don't like negative guys hanging out, you know? We just all positive vibes here. So that's why we're getting rid of him. That's not really why. That's probably not something you want to write on a test unless your teacher has a good sense of humor, but just depends, I guess. So here we go. We're going to get rid of this negative 1 over 25. But before he leaves the island and goes into exile with positive 2, what we need to do is multiply him by the a term, which is negative 5. Why do we do that? Well, because when we did all of this in the beginning, we actually factored out the a term. But that's only for guys that are on the island. Once you leave the island, you have to get back to your original format. So we're going to go ahead, and I always tell people, do this on the side. Obviously, this one isn't too crazy, but sometimes they get really complicated. I tell people, don't try to do your math in the actual algorithm. Do it on the side. Your teacher will see that you've done that, and it'll be a lot easier for everybody. So we've got negative 1 over 5, okay? And again, I just got that because I reduced. So this is what we're going to have here. So we have x squared minus 2 over 5x plus 1 over 25, because I still left the positive one in there. Remember, all positive vibes. Cool, 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 cool. We got it. Perfect. And then here, in exile, I've got negative 1 over 5 plus 2. Okay? So let's take a look now and see what we get as our next step. So basically, what I suggest to people is do this part first before we do anything else. Actually, I'm going to move this up here, you guys, because I know that it cuts off at the bottom there. So let's go ahead and do that end part of the equation, leaving this middle stuff on the island the way it is. So I've got negative 1 over 5, and I'm going to make a common denominator. So we've got 5x squared, plus, oh, that's not a plus. Fixing that. Minus 2 over 5x plus 1 over 25. I hope this is making sense for you guys. If it's not, again, questions in the chat, I'm happy to answer them. And then we've got 9 over 5. Cool. Or we should have 9 over 5. Just 1 second. So now at this point, what we're going to do is we're going to actually make this into the format that we actually care about, which is this. Oh, this isn't it. My gosh, you guys, this is what happens when I try to rush. So I don't want to bore you guys, and then I try to rush, and my letters come out crazy. So please forgive me. So, okay, we want to change it into this format, obviously, because that's what we care about. So what we're going to do then, in order to do that, is we need to change this part into a squared factor instead of a quadratic form. Well, all we need to do in order to do that is take, I'm going to change my pen color here to red so that we really see what the heck I'm talking about. Right here, guys, right over here. This guy right here, we're going to take this guy as he is, because he's perfect just the way he is. It's beautiful just like that. And we're going to plug him into this format. So this is going to become 5 because the A term does not change. It is standard. And then from there, what we want to do is have x minus 2 over 10. Which we can even actually just reduce to 1 over 5. Squared plus 9 over 5. Okay, you guys? So I'm going to let you guys have about 30 seconds to kind of take a look at that and see if you have any questions. And that way I'm not rushing through and then people are asking questions and I'm coming back. So feel free to ask any questions that you might have. Give you guys about 30 seconds there. Okay, guys. So again, in general, in math, keeping things as fractions is going to help you. Oh, well, thank you so much, Roman. I appreciate you joining us, and hopefully we'll see you again next Thursday, okay? Have an awesome week, and thank you again. So in math, we want to keep things as much as we can in fraction form. And I know that this was kind of a lot at once, so we are going to do other examples, you guys. But I do want to make sure that we understand what's happening first before we move on. So remember, this is called vertex form. And the reason this is called vertex form is because this actually tells us the vertex of our quadratic equation, basically. So the way that it tells us the vertex is, again, I'm going to just copy the answer here. X minus 1 over 5 squared plus 9 over 5. And take a look at each thing. So like I said, remember, the A term, that tells us the direction of opening. In this case, it's a positive, meaning that we're going to have a minimum value, meaning that the vertex is at the bottom of the graph, okay? And here we've got HK. HK tells us what it is that we need to know. So one thing that I want to make very clear is that the H, which is the X of our vertex, is always going to be the opposite value that we've got here. I'm trying to indicate this all together. So here it's negative 1 over 5, which means that for our actual understanding of where the vertex is going to be, it's going to be positive 1 over 5. And here the exile island K is going to be the same value that it was. So if it's positive here, it's positive in that as well. Okay, so that means that we've got a graph that kind of looks something like this. It's like positive 1 over 5, which is 0.2. Like say that this is 1, and this is 2, and this is 3, and this is negative 1, and this is negative 2, and this is negative 3. So here we would have our vertex at approximately 0.2 and 9 over 5, which is 1.8. So something like that if this is, 1, 2. So let's say that that's 2. Actually, let's put it a little higher. So it looks something like that. And again, this is just kind of to illustrate what I'm talking about. We're going to do this a little bit better in the next steps. So again, vertex form tells us the very, very important information about where the heck the vertex is and whether or not the vertex is at the top of the graph or at the bottom of the graph. And because in this case, this is a positive opening upwards graph, the vertex is at the bottom, okay? So I know this looks like a serial killer wrote it, so we're going to do another example. But just to kind of reiterate the steps here from converting between quadratic form to vertex form, it's super important, guys, that we understand how we got from there to there, okay? And again, if you have any questions, feel free to leave them in the chat. Okay, guys, so let me just pull up the question that I want us to do next. I'm just dropping stuff everywhere. Super classy, I love it. Okay, so the reason that we did that first example with an A term that's greater than 1 is because I find that that's actually a better way to illustrate the points of this type of question. But again, when we are doing this, we will be getting questions that look something like this. So we have just a 1x squared plus 14x minus 15 equals 0. And again, we want this all to equal 0. That's just how, just like with factored form, it makes life a lot easier. So let's go ahead and do some solving here. So if we've got something like this, we are going to, and again, 0 is y. Sometimes you'll see it like that. Either way is fine. Okay, guys? So let's go ahead and start with our first step. So again, we're creating an exclusive club here on the island of just the guys who have X's, and this guy, including his sign, get exiled from the island. We don't love him. He has to go. Okay? So that's what's happening so far. Again, this is not something that most teachers show. You don't have to actually draw brackets. This is more for us to visualize what the heck is going on in questions like this. Let me just move this over here to get started. Okay, guys, so let's keep on going. So we've done that. And you know what I'm going to try to do is alternate between colors for the steps so that you can see like which step is which step. Okay, guys? So here, next step. We want to take out the A term. Well, in this case, the A term is just 1. So there's not much to take out in the sense that it doesn't actually change anything. But if it was negative 1, it would change the sign. Okay, guys? That's something to be aware of. So this is chillin'. It did not really change. And at this point, we're going to take positive 14 right on over here to our death box. Coolio. So, in the death box, what do? We chop off its head, and I made the death box way too large, but that's whatever. It's fine. So we chop off its head. So remember, we're taking positive 14 as it is. Well, positive 14, just like any number, is over the number 1, technically. Multiply it by half, and I get positive 7. And remember, the sign is super important in terms of the fact that, like, later on it's going to matter to us. Okay, the size here is bothering me. Sorry, guys. So now we're going to take this number that we just got, and we're going to multiply it by itself, which we know is 49. And because it's not a fraction that can be reduced, we're leaving that number just the way he is. He's perfect just as he is. So next step. Let's do the next step in purple, just to illustrate things a little bit nicer. I say as I make the ugliest equal sign of all time. Okay, guys, so we're going to take this number, and we're plugging it back in as a positive and a negative inside these brackets, okay? So let's go ahead and do that. Plus 49, minus 49, and minus 15 stays exactly the way it is. Cool. And now, like I said, we want all positive vibes only. We don't want to keep this negative guy in here, so we're going to get rid of him. And in this case, because the A term is just 1, it's actually going to stay exactly the way it is. So let's use this color to bring it out. So we've got 1 x squared plus 14x plus 49. And the negative 49 is kicked off the island. And for those of you who have maybe seen Survivor, it's kind of like that, where they kick someone off the island. There's no voting, because we just kick off the negative guy, but something to remember. And again, I believe in something called narrative-based math teaching, narrative-based math instruction, which is that I like to add a story to things, because I find that oftentimes what stops kids from doing really well on math tests is not that they're bad at math or that they don't have the computational skills that are necessary. It's that it's really hard to remember steps. And so that's why I give things crazy names like the death box, which I hope no one just rolls in right now and sees this saying death box, but that's okay. So that's why I give things a crazy name like death box or off the island or whatever. I mean, maybe I'm a little bit kooky myself, but that's fine. As long as you guys are getting the right answers and you're doing things properly, I'm okay with you thinking I'm a little bit crazy. I always used to tell my students, when you're sitting on a test, think of the crazy explanations that I gave you as a way to guide you through these questions. Because when you think of things as a story, it makes it so much easier to remember it. And this is kind of a difficult algorithm to remember. Okay, guys, so like I said, we exiled the negative vibes off the island. We're going to take that information and synthesize it. So some people like to do one step over the other step first. It doesn't really matter which step you do first at this point, whether you want to consolidate these. So this is going to be negative 64. Or if you want to change this one into the format that we need for the final step. But regardless of what you do, it's going to equal the same answer in the end. Okay, guys, so coming over here to, let's use blue. Okay, so let's now get that final step that we need. So again, we're taking this quadratic form and making it into a perfect square. That's really the whole point of this question, right? So the way that we do that is we take this number, positive 7, and we plug it in as is. So we go x plus 7 squared. Super important to remember this squared, you guys. That will lose you a nice little mark on a test if you're not careful about that. Minus 64. Okay, so we are now in the vertex zone. Kind of corny sounding, but that's okay. This is the vertex form, right? And this is what we were aiming towards the whole time so that we could solve for the vertex. Well, again, like I said, Hong Kong tells us the vertex, HK. So H is X and K is Y. And we know now that the vertex is always the opposite sign of what you have here in your final answer. So in this case, the x is going to be the opposite sign. So in this case, it's going to be -7, and -64 stays the way it is. Okay, if anyone has any questions about what the heck is going on, and there is a math reason behind this, and so I'll explain it, but don't worry about memorizing what I'm about to say, because it's more so that it's just something to know as opposed to something to worry about, okay? So the reason why it's the negative, or the opposite, is that if we look at our standard equation of y equals ax minus h squared plus k, and for example, in this question that we just did, we've got +7 from the death box, right? So basically, I'm plugging the +7 here into this question, but in actuality, in my original equation, which is really what's the most important piece of this, that the standard equation is ax minus 7. Now, hold on one second. I'm going to show you guys something, or I'm going to explain something, but I just want to make sure that I've got this here in a way that actually makes sense for you guys. So, yeah. So basically, we took this absolute value of +7 and we put it here, when in actuality, the original equation is -7. So technically, negative times +7 is going to be negative, which is why this is going to be negative. Again, like I said, I don't want to confuse you guys. That's why I don't often explain this piece, but I know that some people like to know the why behind questions, so that's why I did explain it. In the end, as long as you understand that the h value is going to be the opposite of whatever the sign is that you have as your final answer for the equation, then that's going to be enough for you to find the vertex, okay? I'm also going to teach you guys a cheat for finding the vertex. I don't call it a cheat, it's more of a life hack. So if you guys remember, and if you've done this unit already, your teacher might have asked you, what is the axis of symmetry? So the axis of symmetry is the exact point, the middle point in a quadratic thing. So like, for example, here, the exact middle point, whatever it is. I know that doesn't look exact because I'm drawing it freehand, but like right here, whatever the x value is here, that's your middle point in your axis of symmetry, because that's where the quadratic form is going to be symmetrical around. It's perfectly half and half, okay? So one way that we can solve for the axis of symmetry, which is the x of the vertex, is using this formula, -b divided by 2a. And what they're referring to by b and a are these original things here, ax squared plus bx plus c. So in this case, we have -14, because here was +14. If it was -14, it would have been negative times -14, which makes it positive. But that's another thing for another day. And then we have 2 times a, which in this case is 2 times 1, because a was just 1. And we get -7, which we know is the answer for our x value of our vertex. And I don't recommend you do this on every single test. What I do recommend using this little formula here for is to check if you're completing the square answer is correct, okay? So this is something also that not every teacher asks, it really just depends. But this is something where, like, if you're in a rush and you're not 100% sure if your answer's right, you can go ahead and just literally use this, x equals -b times over 2a, and plug everything in, and you can get the x value of your vertex, and then the y value is easy to solve for because you just plug this in, this number, into your original equation, and you can solve for y. Okay, so hopefully that makes sense for you guys. We're going to do another example that's a little bit more complicated, because I'm a big fan of direct instruction, which means actually giving you guys the opportunity to see the algorithm in as many formats as possible so that when you do get more complex questions, things are not crazy for you to understand, okay? So we're gonna do one more with a positive A, and then we're gonna do one with a negative A, okay? And again, if you guys have questions, that's what we're here for. Feel free to leave them in the chat, okay? So let's say we have this 7, I'm just gonna do with x's. 7x squared minus 16x plus 100 equals 0. Or whatever, doesn't need to equal 0 necessarily. We're just converting. So converting, we want to convert this to the vertex form. Again, let's start off with the first part where we exile the C term. So let's get rid of that bad boy. We don't love him anymore. He's leaving the island. Whoop. There we go. Plus 100. He's now exiled. He's gone. Now we're going to factor out the A term, which in this case is 7. So let's go ahead and do that division, because that's what factoring means, is you're literally dividing something out of whatever it is that you are factoring. So in this case, that means that now 7 is in the front as our A. All that's left here, because this cancels because 7 divided by 7 is 1. And then this stays as 16 over 7x, which is why I chose this question, because they do get kind of complicated sometimes, and it's important to understand how to do them even in situations like this. Okay, so now it's death box time. We take this and we bring him over to the death box area. And first things first, we multiply by 1 over 2. Sorry, I meant to say 16 over 7, which is negative. Remember, that negative sign is important to bring on over to the death box because it's going to matter to us later. And then here we've got negative 16 over 14, which we can also say as negative 8 over 7, because we're reducing it. And then we take that negative 8 over 7 and we multiply that bad boy by itself. Okay, so finally we're going to get 64 over 49. And what we're going to do now is take this number and plug it back in as a positive and a negative. So 7x squared minus 16 over 7x. And I'm just going to use a different color to kind of make sure that everybody's understanding what's going on here. Plus 64 over 49 minus 64 over 49. Cool. And make that plus 100. And remember now, all positive vibes in the island, so we want to get rid of this negative guy. We don't love him anymore. And when I say all positive vibes, I don't mean that these numbers need to all be positive. I just mean that this negative guy that we added, we don't want him anymore. So we're going to get rid of him, but because we factored out positive 7, we have to multiply him by positive 7 before he leaves the island. So we've got 7x squared minus 16 over 7x plus 64 over 49 bracket. And then I need to solve what is positive 7 times 64 over 49. So I'm just going to do that here. Or like, I mean, when I say I'm going to do this over here, I mean, basically you would do this on a piece of scrap paper on a test or something. And that brings us to 250, no, sorry, I lied. My bad. That's going to be 448 over 49. 448 over 49. And to reduce that, it's actually going to be 64 over 7. So here we've got negative 64 over 7 plus 100. And in my next step, what I'm going to want to do, move all this up a little bit. In my next step, what I want to do is consolidate this part here to get that k value. So I've got x squared. This stuff all stays the same for now. So we're not going to worry too much about that. And we're going to literally get 64 over 7 plus 100 over 7. So again, I like to do the k part first, but you don't have to. You can do the perfect square part first if you prefer. It's totally up to you. You'll get the same answer regardless of which one you do. So then here we've got plus 636 over 7. And we'll keep on moving up. So now we want to make this a perfect square. So actually bring this down for a second. And the way that we do that, if you recall from our other examples, is that we take this number that we saw. What the heck is that? Just want a normal, yeah. So we take negative 8 over 7 as it is, and we make that perfect square. So it's going to be y equals 7x minus 8 over 7 squared, and then this part stays the same. All right, you guys? So I'm hoping that makes sense for everybody. If there's any part that confuses you, you're more than welcome to leave a comment. That's what we're here for. So again, just making sure that we understand what's happened. We know that, oh, I wanted to make this an A. So we've got x minus 8 over 7 squared plus 636 over 7. Okay, guys, so first we want to solve for the vertex here, and the vertex is obviously, as we know, HK. Oh my god, I wanted this to be H. Hold on one second. Sorry guys, clearly I have not drank enough caffeine today. Clearly I need some more. So the vertex in this case, remember it's the opposite sign of the H that you got in the final, so it's going to be positive 8 over 7. And here it's the same sign, so positive 636 over 7. Okay? So now, keeping this in mind, we also know a couple other things. We know the axis of symmetry is x equals 8 over 7. We know that the direction of opening there we go, is positive, and it's upwards because of that positivity. Okay, so these are really important things. Another piece that we do know at this point is our domain and range. So there are a couple different arguments about the domain. Now, in this case, I'm going to assume that this is an infinite function, and that therefore the domain is going to be infinite, meaning that it's not affected by any, real life situations. Keeping that in mind, the domain is basically there to tell you what are the actual possible values of x. And in this case, because this is an infinite function, our values of x are infinite. So in that case, we're going to have the domain like this. We always write this because this is x is a, I forget the exact way to say it, something like x is a function of all reals or something like that. All that matters is you start your domain statements like this, and then you say x, actually no, in this case, this is the answer because this is infinite and it doesn't actually get affected by anything. Now your range is a different story. Your range is all values of y, which in this case, you still start writing like this, but you say y is greater than or equal to 636 over 7. The reason for that is because that's where your vertex is. So obviously, this is somewhere like 8 over 7, which would be like, this is 1. So it would be somewhere over here, but super, super high up. So let's say that like this is where 636 over 7 is, somewhere over here. So it would be like here, and that graph goes up and on forever. Basically what we're saying is that the y value can only exist at 636 over 7 and upwards, because that's the reality of this particular graph. The vertex is a minimum, meaning it's at the bottom of the graph because the graph is going upwards, and therefore the y values only exist from that point up. They cannot be anywhere lower because obviously nothing is happening lower. Okay? So hopefully that makes sense. We're going to kind of get a little bit deeper into what all of this is in terms of graphing, and then we can go from there. So I'm going to just pull this up here and expand this. So let's take a look. Whoa, there we go. That's not what I'm trying to do. I'm trying to make this so that it's like that so you guys can see. Okay, so let's say that I've got something like this, and I've got a graph that's something like that. Pretend that that's symmetrical, guys. Pretend that my drawing skills are something to write home about. Here we go. I never said I was an artist, you guys. Just here to help. Okay, let's pretend that's symmetrical. Okay? So, pretend this goes on and on forever. So you'll see questions like this, and I don't mean exactly like this, but I mean you'll see questions where they give you a graph to look at, and they basically say, okay girl, figure it out now. You've got the information. We want the equation. Okay? And I know that your teachers aren't gonna, oh, that ruined it. Dang it, I wish they could go together. Okay, we'll just leave it like that. So in this instance, you've actually been given a lot of information just by having this graph available to you. So we're going to take that information and use it to our advantage and actually solve the equation. So remember, there's 3 ways to describe a quadratic form. You've got your quadratic form, you've got your vertex form, and you got your factored form. And as you can tell in the way that I write this equation, and again, when you're first learning this, they don't always teach it like this, but this is actually the proper way to write the factored form. Every single one of these formats has an A term in the front, and that A term is really important. It tells you the direction of opening, it tells you a lot of cool stuff. So in this particular case, we know a couple things. We know our x-intercepts, which would be important if we wanted to use the factored form. Okay, and we know our vertex. Let's use this. It's a cool color. I've never used this color before. Oh, that's why, because you can barely see it. Cool. Well, that's our vertex right there. Okay, so let's use the vertex information to our advantage at this point to see what we can do with it. So I'm going to change this green slightly to something a little less obnoxious. Okay, so let's do a vertex form here. So remember that our vertex form looks like this. And we know that the value of the vertex in this case, just as a coordinate, is -2 and, oh, I lied. That's the y. My bad, guys. It's actually +4, -2. Well, that tells us a lot of really important information. It does tell us that y equals a, because we don't know a yet, and I'm not plugging in an x point yet, but I do know that this here is actually going to be -4, because remember it's the opposite, squared, and this is going to be -2. Well, that's really cool, but we are still not done solving this because we still need to know the a term value. Well, that's not a problem for us. You can actually just take whatever it is that you want, like pick a point on here, and I'm going to pick one of the x coordinates, x-intercepts, because it's just easier that way, because I didn't draw a perfect quadratic equation, and so I can't, like if this was in your class, you could pick anything because your teacher's going to give you one that a computer generated most likely, and it's going to be perfectly drawn. But because I suck at drawing, we're going to just pick the stuff that we know is absolute, and that means that it's going to be this here. So I'm going to go ahead and say, okay, well, my y equals 0, because that is what is the case at the x-intercept. and I still don't know my a term, and I'm going to plug in positive 3, and the rest of this stuff stays the same. So that means I've got 0 equals negative 1 squared minus 2, and I'm going to rearrange this. So I'm going to move this 2 over to the other side. It's going to be 2 equals negative 1a, because negative 1, because negative 1 squared is 1. So basically, all we need to do now is solve for a, which obviously it's already done. And our a term is 2. And the a term actually tells us also whether there is a compression or a stretch. So in this case, it's a stretch. And that's something we're going to talk about next week. We're going to talk next week more about transformations and all of that stuff. The reason that we've done this in this order is because it's actually much more useful for you to understand the mechanics of how this works before we start discussing transformations. I often find that when teachers, like kids who I've worked with, when their teachers teach it this way, they seem to understand it more, as opposed to when teachers teach it in the reverse, where they're teaching the transformations first and then the mechanics. Because if you understand the mechanics, the transformations are no problem, right? So again, that doesn't mean that you can't ask me questions. That's kind of my opinion. Feel free to ask questions because that's what we're here for. Okay, guys, so let's double check everything here, plugging it all in. So our final answer is going to be y equals 2 times x minus 4 squared minus 2. And that tells us this equation right here. That's the equation of this graph. Okay? So I hope this was super helpful for you guys. I know that this is an area of grade 10 math that confuses a lot of people, and if you do want me to go over anything, I'm happy to. We can kind of move backwards in the pages that we're looking at here, and if you do need any help with that, that's what we're here for, okay? And then basically, let's just double check that we covered everything we were gonna do. So now, one thing that we do want to keep in mind is when we talk about transformations in a graph like this, oftentimes it's best to understand transformations in relation to the vertex form, which is the one I've outlined here, because in higher grades you're going to be taught different versions of this kind of equation, and you're going to learn it with trigonometric functions, which we're going to do in a couple weeks for you guys as well. So it's really good to understand what each thing means. And so that's why I was saying next week we're going to kind of do a better refresher of everything. Before we do that though, what I also want to do is, now that we've got this answer, so I'm going to just write this here, y equals 2x minus 4 squared minus 2. I'm going to do the same process that we just did, except in this case, we're going to solve the factored form. Okay, guys, so here we've got y equals ax minus px plus q. And as you remember, if you probably recall, it's the opposite sign. So I'm going to leave this the way it is, x, and then, sorry, a, I mean, and then it's going to be x minus 3, x minus 5. Okay? But you need to remember that you haven't solved for your a term yet. And the a term, for no matter which format you've put it in, it's got to be 2 because it's describing the exact same graph. So in order to do that, we're actually going to plug in a value. And in this case, I'm going to actually plug in the value of the vertex because that's another value that I know exists for sure. So the value of the vertex, as we recall, is positive 4 and negative dose. And I'm just going to plug those in as x and y. Okay, guys? So let's go ahead and do that. We've got, sorry, my bad. Negative 2 is a times 4 minus 3 times 4 minus 5. And remember, no matter what age we become and how crazy the math gets, we always need to follow BEDMAS. And so in this case, we're doing our brackets first, so we'll leave everything else the way it is. And we've got 4 minus 3, which is 1. And we've got 4 minus 5, which is negative 1. And that means that in the next step, we're going to do 1 times negative 1, which is negative 1, times a, which is negative 1a. And solving for a, because we can't have a negative a, obviously we need to get it by itself, we're going to just divide off -1, and we get a equals 2, which means our final equation is y equals 2, x minus 3, x minus 5. Okay, guys? So I'm going to put that here. So we solve this here. Y equals 2, x minus 3, x minus 5. Okay, well, last but not least, before we wrap everything up, now that we've got these two different ways of explaining this, and again, remember, this is the exact same graph we're talking about. It's just different ways of talking about it. Factored form tells us our roots, aka our x-intercepts, and vertex form tells us our vertex. And the quadratic form, a lot of people are like, oh, quadratic form's dumb, it doesn't tell us anything. It does tell us things because we can actually use it to solve for the axis of symmetry in situations where we don't want to do vertex form completely. But it also tells us the direction of opening, just like all of them do, right? Oh, did not mean to do that. There we go. So let's take a look at this and see how we can convert this. What we're going to do is actually do an example with both because a lot of people get confused. So if we've got y equals 2x minus 4 squared minus dos, super far away, there we go, minus 2. All right, guys, so when we're doing this and expanding it, obviously we can expand this to get it back into quadratic form, but we have to do it properly. So remember that this here squared means we're squaring this whole thing in the bracket, okay? It means this is going to become this. And then we can use that information to our advantage. So we've got 2. Here in these brackets we've got x squared minus 8x plus 16. And then I multiply this guy in. So I've got 2x squared is what I meant to say, minus 16x plus 32 minus 2. And my final answer is this. Okay, and you can always check that, like you can go back and forth and convert, and it's not too crazy of a concept to just convert between them. But the reason I showed this is because I've actually seen this on tests a lot of times where teachers ask kids to convert back from the vertex form into the quadratic form, and then a lot of people either skip a step or they do this step with the squared, like expanding the squared term. They do that backwards. So something that's really important for us to understand, okay, guys? So what I'm going to do now is just basically I'm going to, stop talking for a second and stop driving you guys crazy and leave about 30 seconds before we wrap everything up so that if anybody has any questions, you can leave them in the chat before we close the hour. So if you do have questions, please feel free to leave them in the chat right now and I will answer them, okay? All right. So it doesn't look like anyone has any questions, but if you do, we're going to be back here next week, same time, same place. You're welcome to come back with any questions you might have, even if they have nothing to do with the lesson. And that's pretty much a wrap for today, you guys. I want to thank you for joining us. I hope that this was helpful for you, and I hope you're having a wonderful week and that you're healthy and safe and feeling good. I know that it's a crazy time right now, but we're all in this together, so if you do need any help with math, feel free to come back again next week, and we're going to do our best to help you as best as we can, okay? Have a wonderful day, and talk to you guys next week on Thursday at the same time, same place. Thank you guys. Have a great week. Bye.